This is the final presentation for EE450 capstone project for Timothy Sheehan and James Arkadie for Grantham University. For our final project, we chose to design a device that we call the Automated Driveway Lighting System. Our system would make it easier and safer for homeowners, especially those that live in rural areas with long driveways, to make it to their parkway and park their vehicles safely. We designed the system so that it would have several features that include automatic discriminatory sensors to detect a passing vehicle, a fluent flow lighting system with timing circuitry which would turn off and on as a vehicle passes by, circuitry for activating the exterior light of the home, as well as circuitry to activate the home's doorbell system, which would announce the approaching vehicle to anyone inside the home. This slide depicts exactly what type of homeowner would benefit from our project. The project will be considered a success by demonstrating the functionality of the discriminatory sensor for the passing vehicle, the timing circuitry correctly providing fluent flow of lighting, and the exterior home lighting and doorbell system being activated. Because this would be such a large undertaking, both monetarily and time-wise, we concentrated our efforts in developing the appropriate circuitry to demonstrate the functionality of each of the aforementioned aspects. For the project, we utilized multisim and virtual breadboard to develop and simulate the circuitry in order to complete a working model for our design. What you see now is the overall design for the ADLS. The next three slides are schematic snapshots of the timing circuitry, the interface of the timing circuits for the driveway lighting system, home exterior light, doorbell assemblies. Now, following along with the multisim simulation, you now see a snapshot of the circuit as it is activated by pressing A on the keyboard. This simulates a passing vehicle and the timing circuit SC4 is activated and the LEDs 3 light up, which represents the driveway lighting. LED 2 is also activated, simulating the home's exterior lighting system being activated. Activation of SC3 after a slight delay simulates the activation of the home's doorbell assembly, which announces the approach of a vehicle. The lights would shut off one by one after a time as the vehicle passes by. In the simulation, to reset, we simply press B on the keyboard to reset the timer and the values for the system. To override the system and have the lighting system always on, we press the space bar on the keyboard to activate S2, and both LEDs 3 and 2 are activated for the home lighting system and the driveway lighting system. We now have a slide here that shows the actual physical buildup of the breadboard. The measured timing delay based on our calculations did not match up exactly to our build. Our calculations for the timing delay was around 0.85 seconds, and in the simulation the delay was around 1 minute. Actual testing on the breadboard was just over that. You will now see the breadboard in action.
Simulate sensor. All three sensors are on. Simulate override. All three are on. Timing circuit, driveway lights, exterior home lights, and doorbell announcing system.
In all, we consider our project to be a success, as the small-scale design demonstrated the functionality of each subassembly and in theory would work on a large-scale production. This concludes our presentation on the automated driveway lighting system for EE450 Capstone with Grantham University.